So, ladies and gentlemen, today we're going to take a little bit more of a look at different types of plate boundaries. First of all, what are plate boundaries? What are the different kinds? And then we're also going to take a look at what we can expect to find at different kinds of plate boundaries, as well as some examples from around the world. As we go through this particular lesson, you are going to be filling in a chart that looks like this. I will tell you that as far as filling in the chart goes, the only time you need to fill anything in or write it down is whenever you see a slide that has either this chart on it like this, or it has a portion of the chart. Other than that, sit back, listen, and understand, okay? All right, so ladies and gents, we're going to start by talking about what is it that happens at plate boundaries. All right, plates can do one of three things, or at least they can do one of three things at places where those plates meet, which is what a plate boundary is. So they can either converge, which means that they are colliding or moving toward each other or coming together. You can see here that when they converge, there is crust that gets destroyed. We'll talk more about that in a little bit. They can diverge, which means to divide or to move apart or move away from each other. When this happens, new crust is created. And then the third thing that can happen is they can transform. And when we say transform, what we mean by that is that they are kind of sliding past each other. Most of the time, that means they are sliding past each other in opposite directions. Other times it actually can mean that the two plates are sliding in the same direction, but at different rates, so at different speeds. So one is going a little bit faster than the other, and so these plates, although this diagram doesn't really show it very well, these plates don't necessarily have these nice, perfect edges as we see here in the diagram. Instead, real-life tectonic plates are rough on the edges. They have bumps and things of that sort. And as those bumps run into each other, that can cause problems, even if they are sliding in the same direction. If they're going at a different speed, these bumps are going to get caught on each other and hit each other. All right, so here is your chart. We are going to go ahead and fill in a little bit of information here, and we're going to fill in the first column. We're going to fill in the information about direction of movement. So for divergent, I'd like you to draw two arrows that are pointing away from each other, and also include the word dividing there, so you remember that divergent is dividing, right? For transform, we're going to draw arrows going in the opposite direction of each other. Like I said, they can occasionally go in the same direction. Most of the time they go in opposite directions, and we're going to write the word sliding for that. For each of the convergent plates, and you'll notice we have three different kinds of convergent boundaries here. We have a continent to continent, a continent to ocean, and an ocean to ocean. We're going to talk about all three of those different kinds, but for right now, you're going to put the same thing for them. You're going to put two arrows going toward each other, and you're going to write the word colliding. If you need to pause the video, go ahead and do that now. All right, so ladies and gentlemen, we're going to start by talking about divergent boundaries, meaning that they are moving away from one another. They are dividing. So we can have a case where there are two oceanic plates that are diverging, and when this happens, a mid-ocean ridge is formed. And basically, that's like a mountain chain underneath the ocean, okay, down on the sea floor. We often call this whole process seafloor spreading, because it's like the floor of the sea is spreading apart as the two plates move apart from one another. Up through the crack comes magma from underneath, from the asthenosphere and the mantle, and as it hits the cold water, it cools, it hardens, causes new part of the sea floor to develop, which then also pulls apart, and the whole process begins again. So new crust is created at these divergent plate boundaries underneath the ocean. You can see that the mid-Atlantic ridge here that goes right through the Atlantic Ocean. That is where two plates come together that are moving apart from one another. You can see there are others like the Southwest Indian Ridge, the Pacific Antarctic Ridge, and others as well. We can also have divergent boundaries that occur on land instead of underneath the ocean. So when two continental plates diverge, I hope I said diverge before and not converge, but when two continental plates diverge or move apart from one another, we don't call it a mid-ocean ridge, we call it a rift valley. All right, a rift valley. And so what happens is that, again, new crust is created. The plates are pulling apart. Underneath you have your magma, and some of it comes up through. It hardens over time. A great example of this is the Great Rift Valley in Africa. Older scientists especially would put this in the millions of years category. Young Earth scientists might say that it doesn't always take that long anyways. But eventually water will fill that valley. So actually, I'm going to have you look, before we start filling in our chart, I'm going to have you look at this map down here at the bottom of the screen. And you'll see we have the Great Rift Valley here. There's another kind of portion of that rift here. And you can actually see in the places where plates are pulling apart from one another that we actually do have lakes that have formed. In the middle of all of this pulling apart here, we have Lake Victoria as well. So, scientists believe that eventually this part of Africa over on the eastern side is going to pull apart from the rest of Africa. We can see where that's located on the continent of Africa here in this area. All right, let's go ahead and fill in our chart. So for our description, we've got a couple of things, so leave yourself some room here. But when there are two oceanic plates, we have a mid-ocean ridge form. We know that seafloor spreading happens here and new crust is created. But when it's two continental plates, new crust is also created, and our best example would be Rift Valley, okay, or excuse me, a Rift Valley forms. Our examples would be the Mid-Atlantic Ridge, if we're talking about oceanic plates, and the Great Rift Valley in Africa, if we're talking about continental plates. Again, go ahead and pause your video if you need to fill this in. Next, we're going to take a look at transform boundaries. Those are the sliding plates. Okay, the plates slip sideways past each other. It creates a lot of earthquakes. Not to say that there aren't other plate boundaries where earthquakes happen, but you definitely are going to experience earthquakes along a transform boundary where the plates are slipping past each other. In this case, crust is neither created nor destroyed. Pieces can be broken off, but the pieces of crust are still there. They're not getting melted down into the mantle or things like that. So it's not destroyed. It may be changed, but not destroyed. Neither is it created in these types of boundaries. A lot of these are found on the seafloor, but you can see here in the picture to the right, there is very clearly one there that's on land. And in fact, the most famous one, at least for us as Americans, would be the San Andreas Fault in California, and that is largely on land, although it is pretty close to the ocean. So again, we're going to fill in our chart here about transform boundaries, but you can also see underneath the chart, we've got a map of California that shows, the red line shows where the San Andreas Fault is, where it's located. And you can also see how these plates are moving. It's why California has so many earthquakes, is because of the San Andreas Fault and because those plates are slipping and sliding there. All right, a lot of earthquakes happen, of course, at transform boundaries. Crust is neither created nor destroyed, and they are often, but not always, found on the seafloor. Our best example that we're going to give here is the San Andreas Fault in California. Again, you may pause your video if you need to fill this in. All right, lastly, we're going to talk about converging or colliding plates, convergent plate boundaries. But we're going to talk about 3 different kinds. So continental to continental, this forms folded mountains like the Himalaya mountains, which are the tallest mountains in the world. It's where Mount Everest is located. Continental plate to an oceanic plate, when those collide, volcanoes form. An example of this would be in the Cascade Mountains of Oregon and Washington State. And then also we're going to talk about oceanic to oceanic plates. When those 2 plates collide, you often get a volcanic arc of islands that form. The Aleutian Islands of Alaska are an example of this. So we'll start with continent to continent. So a continental to continental boundary where you have 2 continental plates that are colliding with one another. You can see in the map over here to the right, here is India, here is China. In between them, we have the nations of Nepal and Bhutan, which are located in the Himalayan mountains. The Himalayan mountains kind of form part of the boundary between India and China, and then these small nations of Nepal and Bhutan are also located in that area in these incredibly high folded mountains that have resulted as from the impact of the collision between 2 continental plates. The 2 continental plates are colliding and pushing against each other, and all of that pressure together creates a folded mountain. Okay, one way you can kind of demonstrate this, other than what we've done in the lab activity, but if you were to take a towel and place it nice and flat on a table, put your one hand at each end of the towel, and then slide your hands together, okay, that is going to kind of represent the pressure that causes these folded mountains to form. It's kind of really an incredible amount of power to form the very tallest mountains in the world. There is no what we call a subduction zone when we have 2 continental plates colliding. We'll talk a little bit more about what a subduction zone is in a couple minutes, but basically it means that one plate doesn't slide underneath the other plate. They just come together and fold because of all the pressure. All right, so we are going to fill in the top part here for continent to continent convergent. Both plates have the same density. One plate isn't more dense than the other. If it was, then one would go slide underneath the other one. But because their densities are the same, that doesn't happen. Creates folded mountains, and the most famous example of those would be the highest mountains in the world, the Himalayas, including Mount Everest. Sorry, go ahead and pause the video if you need to in order to fill that information in. All right, next we're going to take a look at when you have a continental plate and an oceanic plate meeting and converging together. All right, the oceanic crust, we talked about this when we talked about the layers of the Earth, and we originally started talking about plates and the crust. Oceanic crust, of course, is more dense than continental crust. Remember, it's had all that ocean sitting on top of it, compressing it, and it's made of basalt instead of granite, basalt being more dense than granite. And so the oceanic crust then sinks or subducts underneath the continental crust, which is less dense. This is called a subduction zone right here, where the crust is subducting or sliding beneath the rest. Volcanoes form because as the crust subducts, it begins to melt as it gets hot, forms this little pool of magma underneath the surface of the Earth, pressure builds up, and the volcano is formed. A trench also forms where the 2 plates come together, a little V-type trench. And as I mentioned a moment ago, we have the subduction zone where the plates, the oceanic plate slides underneath. Over here we have a map that shows the Cascade Mountains in Oregon, mostly in Oregon and Washington State. Probably the two most famous of those are Mount Hood, which is well known for its skiing and things like that. Well, also Mount Rainier, but then perhaps the most famous of all, Mount St. Helens, which is a volcano. Several of these mountains are volcanic or have been at one time. Most of them are not particularly active, but Mount St. Helens did rupture in the 1980s and has at other times shown signs of possible future ruptures. We're going to fill in the continent to ocean. Ocean crust subducts below continental crust. Ocean crust is denser, which is why it subducts. Trench forms and volcanoes can form. And the Cascade Mountains of Oregon and Washington are our best example. Go ahead and pause the video if you need to at this time. All right. Finally, we're going to talk about converging boundaries of oceanic crust and oceanic crust, or oceanic plate and oceanic plate. When they collide, they push against each other. The older crust subducts or goes below the other one. The older crust has been compressed for more time, and therefore it is more dense. And this can create a volcanic arc of islands. And the Aleutian Islands that kind of form the tail of Alaska, I don't know how else to describe it other than a tail. You can see it there in the map. Those are believed to have been formed because of two oceanic plates colliding. Again, there is a subduction zone here where one plate is subducting underneath the other. Go ahead and fill in the last part of your chart here with the information about the oceanic to oceanic plate boundary, converging boundary. And thank you, ladies and gentlemen. Make sure that paper gets into your binder. Have a great day.